I wanted to show you guys this book as if you ever go to the library, I would check out, or you could maybe, I don't know if you can rent books from Amazon or however it is you guys do that these days. I actually have a paperback copy of the Cartoon Guide to Chemistry, and it's by Larry Gonick, I think that's how you say his name, and Craig Griddle. And Griddle, I don't know how you say that. Anyway, it is actually cartoons about chemistry. And if you are planning to go into science or engineering, or you want to be a successful student in chemistry, it is worth you picking this up and taking a look at it. The reason I bring it to your attention today is because chapter 1 is about how chemistry really all kind of got started. And I like to talk about this when I'm introducing the subject of chemical equations and the conservation of law of conservation. Okay, so briefly though, you can, maybe I'll zoom in and you can take a look at some of these pictures here. Let's see. You probably won't be able to read it, but I'm just going to talk about them a little bit. So there we go. So if you want to think about chemistry going all the way back to the time of the caveman, and when the first chemical reaction was fire, right? So fire is where we give off that release of energy that we were talking about in terms of light and heat. So the caveman realized that something was going on when you burn stuff, right? So naturally, you give a scientist something to do, and they're going to keep doing it to all kinds of different things. So they started out burning wood, and then before you know it, well, they're burning sticks and rocks and leaves, and and they're burning rocks of all the silly kinds of things, and rocks are rocks is kind of a general term. You can have rocks can be minerals, they can be ore, you could have metal. Ore is called a rock, right? So when they stumbled across maybe a red rock and started to heat it up in the fire, then it melted, and they were really freaked out because wow, there's a state of matter right there changing in front of our very eyes. So chemistry kind of goes all the way back to the caveman days. And so people, did experiments trying to make chemical reactions happen, trying to make one thing turn into another. Now, this was something that people did all through time. And especially in the days of kings and kingdoms, the king had his own staff of shamans and magis and religious folks that he would employ to wield his power. So if the king said, I want you to go and convince all these people over there in this other kingdom that, they need to become part of our kingdom, and so that we can have their land and all their bounty, well, people just aren't going to give that up willingly. So you had to do some magic or, do something to really freak them out or scare them, right? So that's where the magis and the shamans came in. And the king would send them down to the laboratory in the basement of the castle to come up with all this, some concoctions, And of course, the big ticket items were gold and money and weapons, right? So gold and gunpowder, right? So that was something that was really sought after by the kings in order to, win the hearts and minds of his competition, so to speak. So these guys would go down to the basement and they would try all kinds of crazy stuff, and they even tried something as silly as boiling urine to produce gold. So they would go out and they would collect buckets of urine from the horses and the mules, and they would boil it down, and they would be left with this, yellow flaky substance. Well, it wasn't gold, it was phosphorus. But the idea was that all matter be boiled down to basic ingredients, and if you just mix those ingredients in different proportions, then you then you can invent, or you can create whatever you want, right? That was the logic at the time. And so, the most basic elements were earth and wind and fire and, all those kinds of things. But then they expanded to, to gold and copper and carbon and those kinds of things. And they thought, just like a recipe, if you had milk and flour and eggs, if you just changed the proportions, then you could make waffles or cupcakes or pies or whatever it was. So this whole idea of doing mixing things together, it wasn't really chemistry at the time. It was called alchemy. And alchemy was, let me see, flip a couple of pages here. Alchemy really wasn't a bad thing because they were producing results. They were actually doing things in the lab, but it really wasn't scientific. It was more trial and error was what they were doing. And it wasn't until a guy came along named Lavoisier, and you'll read about Lavoisier you'll read about the father of modern chemistry in your textbook, but he was one of the first people to be scientific and apply the law of conservation of mass. He said, listen, when you burn the log isn't disappearing. It's not like magic. He says, what if you could capture everything that was going up in smoke, then you would find out that the mass stays the same. So let me zoom out here and try to maybe visualize that for you a little bit better by doing some drawings. We'll talk about chemical equations in a minute, but chemical equations are all based on this law of conservation of mass. So I thought we talked about this a little bit earlier. Say we had some logs on a fire, and right? So this has a certain mass to it. If you would put this, I'm going to try to draw some tippy balance scales here, and we have some scales over here. Now, if you, to the non-scientific person, to the non-scientific person, it looks like I made a big pile of poo there, right? But to the non-scientific person, you would think that the logs are going to weigh more than the pile of ash. But Lavoisier was one of the first guys to say, no, look, whatever we started out with is really what we have to end up with. And you can't just weigh the pile of ash and say that some mass had disappeared. You have to include all the smoke and the particles that went up into the air. And if you did that, then you would find out that those would be in balance, right? So the law of conservation of mass states that we do not create or destroy matter. We're not God. Matter just gets rearranged. It gets transferred from one thing to another. So I want you to keep this idea of keeping things in balance, because today we are going to be talking about chemical equations, and that we react things together and we produce products, right? So you have the reactants on one side and the products on the other side, and that this chemical reaction kind of moves forward in this direction so that those reactants yield or produce products. Okay, so I want you to keep in mind that the chemical equations are all based on this law of conservation of mass, which I've tried to visualize here.